Saxon Algebra 2, lesson 79. This is a two-part lesson, and I'm going to switch the order of the two parts because I want the second part to land more firmly into your brain. It's one of my favorites. I really love it. And it's going to become, as we go on, it's going to become more and more and more your favorite, I promise you. And I hope you have favorite lessons. I wish I could ask you right now what your favorite lessons were and learn about that. I've been teaching this class for 21 years, and I definitely have my favorites. Okay, but that's not why we're here. We're here to talk about 45, 45, 90 triangles. Now, before we dig into those, let's go back and refresh our memories about these 30, 60, 90 triangles. Remember that the name refers to the degrees in the three different corners of the triangle. Technically, I should have degrees on these, shouldn't I? And we talked about how to draw and memorize the 30, 60, 90 triangle. I told you to start by imagining a backwards play button, right? It's an equilateral triangle. Each one of these sides is 2. And because it's got the same length sides, it's also got the same size angles. They're all 60 degrees because that adds up to 180, right? And they must. Now, what we're going to do is we're going to take our cute little triangle and we're going to divide it right down the middle. That's going to create a straight line. And what we're going to do is we're going to redraw the top half of this over here. And I'm going to make it a little bigger. Now, let's take a look at what we know about the angles and sides of this. We know that this is a 90-degree angle because we just chopped it. This 60 up in this corner, that stayed exactly the same. We didn't touch that. This 60 here, we chopped that in half. So this has become a 30-degree angle. Oh, look, 30, 60, 90, just like I promised, right? Now let's look at the sides. This side is exactly the same. So this we know is 2. This side that was a 2, again, we chopped it in half. So now this is 1. This side, we will use Pythagorean to solve for it. This is one of the legs. So 1 squared plus, what should we call it? B squared equals 2 squared. 1 plus B squared equals 4. Subtract 1. B squared equals 3. Square root, this side is square root of 3. And what I hope you have learned, because I told you this and I think you probably have figured it out for yourself, it's fairly easy to remember this because we can remember the 1 and then the 2 and then there's a 3, but there's a trick to it. It's not just a straight 3, it's a square root of 3. This we want to memorize. And while you can just look at this and memorize it, if you can remember this triangle that was in red and then how we convert it into the green, then that will be easier for you than trying to just memorize this randomly, all right? It's a lot easier if you can recreate something than just trying to memorize it. Okay, so that is the 30, 60, 90 triangles that we've talked about. And I think you may remember me telling you that the 30, 60, 90s are the more complicated of the two different types of triangles. 45, 45, 90 is easier. And I'm going to draw it 2 ways just because it's so easy to visualize. In this triangle, we have 90-degree angles. And then the other 2 are both 45. I'm drawing it going in both directions just for fun. Here, we started out making the sides each 2 because we were going to cut them in half. We don't have to be that fancy this time. We can just make both of our legs, if you will, 1. Now, if you use Pythagorean again, which I don't even want to take the time to do, you'll find that the hypotenuse is square root of 2. That's it. There it is. 45, 45, 90, 1, 1, square root of 2. This is our new triangle. Do you see what I mean? This one's even easier than the 30, 60, 90. Okay? So we want to commit this to memory in the same way we committed this one to memory. Like I said, this, I hope, goes way faster into your brain. Okay? And we talked about this, that when you have a 45-degree angle, that means both angles are the same. That means these two sides are going to be the same. And that means that the cosine and the sine of these angles are going to be the same. So 45, 45, 90-degree triangles are just kind of peaceful and relaxing. All right, let's try, there's just one problem that goes with this, and then we'll loop back and get that other topic in this lesson. Example 79.4. Use similar triangles to find x and y. Now that seems confusing to me, so I'm just going to draw the picture. And this is what we get. We're told this is a 45-degree angle. That's a right angle. X, Y, 7. What we are supposed to recognize is, aha, this is a 45, 45, 90 triangle, so we can use our memory triangle, if you will. John often calls it a reference triangle. That's cool. But I'm going to draw it little. 45, 45, and it's 1, 1, square root of 2. That's what we have memorized. Now what we can do is simply create proportions. They're similar. John told us that. We can see it for ourselves, right? Similar triangles have the same angles but different length sides. We're fine with that. So we look for an anchor proportion. Here it is, the 7 and the square root of 2. So 7 over square root of 2, this triangle over that triangle, equals x over 1, and the same reference side will be equal to y over 1. Oh, that's pretty easy, right? So we're just creating proportions as we have been doing for a billion years or 20 weeks. And the way these turn out is simply beautiful because these are over 1, so there's nothing to simplify, except for these radicals. We better make those go away, right? So we'll rationalize the denominators on both sides, and then this will become x equals 7 times the square root of 2 over 2, and this side will become y equals 7 times the square root of 2 over 2. That's our final answer. If we wanted to, we could grab a calculator. We could calculate the square root of 2, multiply it by 7, and then divide that by 2, and reduce this to a decimal number. It's not necessary. In this course, we are perfectly happy to leave hand calculations only and not take everything into the calculator. But we could convert that to a decimal number if we wanted to, right? That would be easy. Okay, there it is, our new friend, the 45, 45, 90. We're going to be using him for a long, long time. I'm going to send him off to college with you and your friends. Okay, let's go to part A. This is called metric volume. I know. It's kind of a train wreck to go into such a different direction now, right? But we're going to talk about the way volume units work in English versus metric. In English, the English units, the English system that we use, if you want to find volume, we usually take some unit of length and we cube it. So for example, if we wanted to find the volume of this box, it might be in centimeters cubed, or it might be in yards cubed, or it might be in inches cubed. I shouldn't say centimeters because that's not an English unit. Feet cubed, right? We would say that we would measure each of these as a length, and then we would multiply them all together. So it's a unit of length. Let me just write that. That might help. all right? In metric, you can do it the same way. A volume can be equal to a unit of length cubed. Like I just said, our little square, it could be centimeters cubed, or it could be meters cubed, right? Anything like that, it's fine. But we also have something special. We can measure volume using a unit of volume. It's a whole different kind of measurement that we don't really have in the English system. So that's why for us Americanos, this kind of blows our mind. If you're comfortable with the metric system, you already know this and it seems quite normal, and it's weird that the English system does not have something similar. But I'm gonna give you the unit of volume that we will use. Notice that we don't have to cube it. Right? When we take a unit of length to measure volume, we have to cube it to get the 3 dimensions, right? But when you use a unit of volume, you don't have to cube it. All right? This is the unit of length. It's cubed. It equals 1 milliliter. This is a unit of volume. It is not cubed. It implies volume just by looking at it. Here, this is a unit of length, and so we cube it. But we can equate those to each other. What happened when they were building the metric system? Somebody really clever took a little ice cube tray that was a centimeter on each side, right? Boop. I'm trying to draw this and I'm not doing very well. Right? Here's our little ice cube tray, and he poured into this water, and he knew that this was 1 centimeter squared. 1 by 1 by 1. So this equals 1 centimeter squared. And then the amount of wiggly water, this is a plastic bag full of water that he's pouring in there. He said, okay, this amount that will fill this up, I'm gonna call this 1 milliliter. I created this unit of measure that will fit exactly inside of there. In the English system, nobody did that. Nobody said, oh boy, if you take a 1-inch cubed measure and pour in half a cup, it'll work exactly. Nobody connected those two measurements, volumes and lengths. Nobody built this nifty, cool little connection between them. But in the metric system, they did. So this is how we equate them. We can also say that 1,000 centimeters cubed equals 1 liter. This is just multiplying this up, okay? And if you look at these two sides, we can also say that 1,000 milliliters equals 1 liter, which is this, L. So these are 3 ways of saying the same thing. It's the same measurement. There are just 3 different useful versions of it. So what we're going to do is we're going to practice doing some unit conversions where we will switch either from a unit of volume to a unit of length cubed, or we'll start with a unit of length cubed and we'll go to a unit of volume. Okay, so we're going to practice going back and forth between these 2 ways of measuring volume in the metric system. Again, in the English system, we don't have anything like that. We don't have a connection between our volume and our length measurements. They're random and disconnected from each other. Such a pity. Okay, example 79.1. There are 3. And they're unit multiplier problems, so they follow the same general rules as that. Use unit multipliers to convert 14,000 milliliters to liters. Okay, so we're going to have to go from, now this is a unit of, this is volume, a unit of volume, and this is a unit of volume. So we aren't gonna have to go through centimeters cubed, right? We've got everything we need. I wanna write down my formulas up here though. 1 centimeter cubed equals 1 milliliter. 1,000 centimeters cubed equals 1 liter, and 1,000 milliliters equals 1 liter. That's 3 ways of saying the same thing. They're not different, they're just in different denominations, if you will. So they're useful for us in different ways. Here we've got milliliters. So what we can do is we can use this one, can't we? That'll take us right from milliliters to liters. So I'm gonna draw 1 unit multiplier. It's gonna have to sit underneath this cloud. I'll put this over a 1. So from here, we're gonna go from milliliters all the way to liters. We're gonna go in one big jump, and we're gonna use this one. I'll put milliliters on the bottom, and then I'll put 1 liter on the top, okay? Units cancel, yay. This ending unit is what I want, so my number will be 14,000 divided by 1,000, and so our answer is 14 liters. Oh my gosh. The metric system is so beautiful and elegant. It's so much easier to work with. I know you Americanos, we're not used to it and it seems weird, but it's so much better. Someday we will make the jump and I can't wait. Okay, so example 79.2. That was pretty harmless, right? Again, make sure you get these formulas. Pause me right now and copy them if you haven't had a chance to do so. I know I'm going fast. It's because I'm excited about this. You can't live without this. You'll need to memorize these and use them. Okay, 79.2. Use unit multipliers to convert 4 cubic feet. Cubic means 3 times, so I'm gonna write feet, 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 so I can cancel it. And we're gonna change that to liters. Oh, all right, how the heck are we gonna do that? Well, we can see that this is a unit of length and this is a unit of volume. I can tell because this one's cubed and this one's not. So what I'm gonna have to do is I'm gonna have to bring feet down to inches, then convert inches to centimeters, then I'll be able to go over and do milliliters, and then I'll blow it up to liters, okay? So I have to go all the way down to the portal. Remember, the portal is the place where English and metric connect, and that's always between inches and centimeters. So I'm gonna need to do this. Ooh, this is gonna be a lot. First, I'm gonna need to go from feet to inches, and I'm gonna have to do that 3 times, right? I'll convert feet, feet, feet to inches, inches, inches. Then I'm gonna have to go from inches to centimeters. And that's gonna be 3 times, right? Because I'm gonna have to go inches, 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 centimeters, centimeters, centimeters. Then will come the magic. Because once I have centimeters cubed, I'll be able to use this. And I don't have to use it 3 times. I'll use, this will take me from centimeters cubed to milliliters. And then in my last box, oh boy, this is gonna have to really squeeze in. There, my box is going around the L. Then here, I'll go from milliliters to liters, and that will be this one. That'll be easy. And I only have to do that once, okay? So when I'm working in units of lengths, even if they're metric lengths, I have to keep doing the 3 times. But once I get to this magical place, where I convert from units of length to units of volume. Now I don't have to do it 3 times. This has 3 times built into it, and with this one, I don't need 3 times. I just use it as is. So it's weird because we do some multiple times and others not. The stars tell me you don't have to do it extra times. All right, let's go through and see if we can do this. Feet to inches. I want feet on the bottom, and I'm gonna write them all out. Feet, feet, feet. Inches, inches, inches. I want to cancel. Feet are bigger, so that gets the 1. 12 inches in a foot. Feet, 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 inches, feet, 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 sorry. And now we've got inches. Okay, in this one I want to go inches to centimeters. Put the inches down here so they cancel. Centimeters up here. How many, which is bigger? An inch. 2.54 centimeters in 1 inch. Okay, units of length, I need to do it 3 times. It's all good. Let's cross off our inches. And now I'm going to circle them as one big thing. Centimeters cubed. Now I want my centimeters cubed on the bottom, and then I'll have my milliliters up on the top. 1 centimeter cubed equals 1 milliliter. Somebody measured it out. Somebody made a little tiny ice cube tray that was a centimeter in each direction, and then they poured a precise amount of water in there to fill that up, and they said, we're gonna call that amount of water a milliliter. Oh, so smart. Okay, this, again, we do not have to do 3 times. The formula takes care of the fact that this is 3, so we can cancel these 3 against that, because that's cubed. And now we no longer have to do things in 3, because we switched into our measure of volume, our unit of volume. Now we just have to go from milliliters to liters. Look, there it is right there. It gets to go back in here. Which is bigger? A liter's bigger. How many milliliters are in a liter? 1,000. Okay. Notice that here it's 1 to 1. What we're doing is we're just changing up the units, right? This is a really special one. This one's special too, because going from inches to centimeters, I call that the portal. Right? That's how we're changing from one system to the next. All right, so now we're ready to write our answer. It is 4. Now each of these are 3 times. So times 12 cubed, I'm going to use parentheses, I don't want to use dots, times 2.54 cubed, there's a 1, there's a 1, divided by 1,000, and our end, oh, let me see, I gotta cancel those off. There's our ending unit. That's what we want. Liters. 4 times 12 to the third times 2.54 to the third divided by 1,000. Woo! Tricky, right? Again, if you grew up using the metric system, that probably doesn't seem as mind-blowing to you. But for us English people, that's insane. When John writes these out, his answers out, he oftentimes will put the ones. So he has 1, 2, 3, 4, 5, 6, 7 ones in the denominator. I don't need you to put the ones in the denominator. I think that's nutty. One more. Example 79.3. Use unit multipliers to convert 4.7 liters. And my brain goes, okay, that's a measure of volume. That's a unit of volume. It doesn't need to be cubed. It represents, it represents literally like a liter bottle, right? To cubic inches. Oh, that's an English unit of length. So first I'm gonna have to convert this unit of volume to a unit of metric length, because those are all connected. Then I'm gonna have to go through the portal to inches. All right, so in order to switch between the 2 different measuring systems, I have to get this down. Oh, I have to write my things again, don't I? 1 centimeter cubed equals 1 milliliter. 1,000 centimeters cubed equals 1 liter, and 1,000 milliliters equals 1 liter. Again, those are 3 ways of saying the same thing. I like to have all 3 of them in front of me because you never know which one might be the most useful to your problem. All right, ready? Here we go. First, we're going to have to move this into milliliters so that we can change the unit style of measurement. So let's move this from liters to milliliters. We do not have to do that 3 times because that's a measure of volume. Then we'll go from milliliters to centimeters cubed. That'll be this. We don't need to do that 3 times. Now, however, we'll be fully converted to units of length, and we'll have to do centimeters to inches, which is where we want to be. This one we'll have to do 3 times, so I'll put a circle around that. I'll put the stars down here too, because I ran out of space up here, so I'm just writing down here. The star means once is fine. We don't have to do it multiple times. This means we have to do it 3 times because our units will be cubed by then. All right, so let's try this. I want liters on the bottom so it cancels. I want milliliters up here. A liter is bigger. There are 1,000 milliliters in 1 liter. Okay, liters are gone. Now I'm still in a unit of volume, not a unit of length. So that's cool. I want milliliters to cancel. Now I'm switching it to centimeters cubed. Here's where I switch from a unit of volume to a unit of length cubed. Oh, this is when it gets messy. Here's the one that's going to work for me the best here. The numbers are the same. We're just switching the unit. Cancel out the milliliters. That's cool. Now, we're taking this from centimeters to inches. An inch is bigger. A centimeter is 2.54. Centimeter, 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 inches cubed, and our inches cubed is how we want our answer. All right, we did it. So now, oh, I just noticed something. See how we went from liters to milliliters and then milliliters to centimeters cubed? We could have used this middle one and gone directly from liters to centimeters cubed. See, we did it in 2 steps, but we did have a version of our formula that would have allowed us to do it in a single step. So either way is fine, whichever way makes sense to you. Of course, it's always more efficient to go faster, but this also works. All right, so let's do our final summing up. 4.7 times 1,000. I double check and go, oh no, I don't need it 3 times. I've got my star. This is a unit of volume, so I don't have to cube it. Those are just ones. And then we divide by 2.54. And this one we have to do 3 times. And our ending unit is inches cubed. That's the right answer. Whoa. Crazy, right? Kind of fun once you get the hang of them. These are super useful in practical calculations though, because it's quite common for, especially in the States, I don't know about the rest of the world, but it's quite common for us here to get some data in metric and some data in English units and then have to put it together. So this is a very practical thing to know how to do. All right, that's lesson 79. Don't you miss those little 45, 45, 90 triangles? Oh, this was crazy. Okay, that's all. Lesson 80, goodbye, is next.